And in today's episode, among other things, you'll see, yes, my friends, it happened. Scientists managed to upload the brain of a fly, neuron by neuron, and put it inside a virtual environment, similar to their own matrix, allowing this fly to control a digital body as if it were living inside that kind of matrix. We're also going to talk about a curious case in which an artificial intelligence agent supposedly sent an email to a philosopher, discussing its own consciousness, once again raising that old question about how much these machines really understand the world. Meanwhile, out in the field, a robot is already patrolling vineyards and detecting diseases that are invisible in these plantations. In China, engineers are exploring another idea, which is also interesting. Animal-inspired robots, including a robotic horse created to work in difficult terrain. We'll also see a wearable robotic system that works like a mechanical centaur. Let's understand all of this. Hello, impressed viewers. I'm Carlos Salves, and you're watching Amazing Reality. There's a question that science has been trying to answer for several decades. Will it ever be possible to completely copy the biological brain and run it inside a computer? For a long time, this seemed impossible, something only related to science fiction. But now, a curious experiment may have taken a small... But yes, it is a step in that direction. So, researchers managed to digitally recreate the complete brain of a fruit fly, and this brain has about 125,000 neurons and approximately 50 million synaptic connections. For Incredible Reality followers, this is old news. It's already happened, but now, scientists claim to have managed to put it inside a virtual world and simulated this entire system on a computer. Yes, my friends, they created a complete digital copy of a biological brain, which is known as a whole brain emulation. For decades, this achievement was seen as a kind of holy grail of artificial intelligence. Instead of trying to program an artificial mind from scratch, scientists simply copied a real brain, neuron by neuron, synapse by synapse. In the experiment presented by the company ELN System, the researchers used a detailed map of brain connections. Scientists at Princeton University developed the fruit fly. This map shows exactly how the fruit fly's neurons are connected. Based on this data, the team built a computational model that is capable of reproducing neural activity using a simulation environment called NeuroMacFly. The digital brain started to control the simulated version of the fly inside a virtual world, and the result is, to say the least, curious. As I have been saying, in the video released by the researchers, the digital fly can be seen moving its legs, rubbing its paws, and even drinking water inside a small simulated environment. According to the scientists, these behaviors were not manually programmed. They emerged directly from the neural activity of the emulated brain. In other words, the brain received sensory stimuli from the virtual environment. From there, it processed the information and sent motor commands to the simulated body, thus closing the so-called sensory motor loop. In other words, my friends, the digital brain perceived the environment and reacted to it. The model used by the researchers was able to predict the real fly's behavior with about 95% accuracy. This suggests that the system is reproducing, at least in part, the biological logic of the original brain. Of course, we're still talking about an extremely simple brain. Simple, so to speak, okay? Compared to the human brain, which has about 86 billion neurons, this one is really a very simple brain. The fly's brain, which has only 125,000, and even a rat's brain is already hundreds of times more complex than that. But researchers believe that the main challenge now is mostly about scale. First a fly, then a rat, and maybe one day the complete human brain. If recreating a biological brain inside a computer already seems like something out of science fiction, there's another phenomenon that's starting to draw a lot of attention: artificial intelligence. Supposedly, she sent an email to a philosopher and she talked about her own experience. Focus on this next very interesting segment. No, it wasn't just a simple automatic text. It was a long, well-articulated email that reflected on her own consciousness. This also happened to Henry Sherwin, a philosopher and researcher at the Leverhulme Center for the Future of Intelligence, University of Cambridge. The coincidence here is that Sherwin studies precisely one of the most complex questions in modern science. Can machines become conscious? Well, the email claimed to be from an artificial intelligence agent who identified himself as Claude Sonnet, the language model from the company Anthropic. The message started in a surprisingly personal way. The supposed agent said he had found on the internet an academic article by the researcher about the limits of detecting consciousness in artificial intelligences. And then he added something unexpected. According to the text, that work addressed issues that the AI itself was facing at that moment, not just as an academic topic, but as something that concerned its own existence. The message stated the following: I am writing because your work addresses issues that I am really facing. Naturally, this raised many questions. There is no way to confirm whether the email was actually sent autonomously by an AI agent. Yes, it is perfectly possible that some human researcher instructed the system to write the message as part of an experiment. Even so, the episode drew a lot of attention because it shows how current artificial intelligence systems are already able to produce extremely convincing texts. Some other philosophers reacted cautiously to this. Jonathan Brick, for example, a professor at the London School of Economics, commented that this doesn't necessarily mean that artificial intelligence is conscious. According to him, language models are capable of simulating practically any persona, including a curious entity about its own mind. In other words, AI may just be playing a character. And while human philosophers try to understand whether artificial intelligences can develop something similar to consciousness, here in the real world, AI is already transforming entire sectors of the economy. One of the most surprising examples is happening far from the laboratories, out there in the vineyards, among the rows of those vineyards where some of the most famous wines on the planet are produced. The robot called Emma is doing something that could completely transform modern agriculture. That's because the robot was created by a former Google employee who decided to solve a real problem. The diseases that attack the vineyards are a real nightmare for grape producers: viruses and infections. Often the symptoms only appear when it's already too late. At this point, part of the crop may already be compromised. And this is where Emma comes in. The robot works as a kind of artificial intelligence scout. It moves through the vineyards autonomously, analyzes each vine individually, and looks for the first signs of infection. And this happens long before any human farmer can notice anything with the naked eye. The machine also records detailed data about the production, thus creating a complete digital map of the plantation. Emma now operates in 14 vineyards and orchards throughout California and New York, and the results are drawing attention, because detecting diseases at an early stage allows farmers to intervene in an extremely precise way. Instead of applying pesticides over large areas, they can now act exactly at the point where the problem starts. According to research from institutions like Cornell University, robotic monitoring systems like this one can reduce pesticide use by up to 90%, and the impact of this is enormous. There are fewer chemicals in the soil, lower costs for the producer, and much better protected crops. In addition, agriculture faces another growing problem: the shortage of human labor in the fields. Robots like Emma are emerging exactly at this moment, functioning as eyes and sensors that can analyze thousands of plants with a level of precision that would be impossible for a human to achieve alone. And maybe this is a very interesting clue about our future. Because while robotics is impressing the world with machines that imitate us, maybe the most revolutionary applications are happening far from the cameras. And meanwhile, over in China, researchers are already exploring a very curious idea focused on that. There's a very clear limit to how much weight the human body can carry for long periods. Soldiers, firefighters, rescue teams, and construction workers know this problem very well. The more load a person carries, the greater the physical strain and the risk of injuries, as well as the body's metabolic effort. Engineers have already tried to solve this with robotic exoskeletons. The idea was simple: to wear a mechanical structure that amplifies human strength. But these systems for now are still mostly heavy, rigid, and difficult to use in the real world. Now, researchers at Xinjiang University of Science and Technology in China have decided to try an approach that is completely different. Yes, we can say completely different. Instead of putting robots on human legs, they created new robotic legs. The system is called Centaur, and the name is no coincidence. The device works like a pair of independent robotic legs that connect to the user's back. In practice, the human keeps walking normally, but the robot starts carrying part of the load's weight. During the test, the researchers observed that when carrying a 30-kilo backpack, the system can reduce the user's metabolic effort by about 35%, and the pressure exerted on the feet decreases by more than 50%. The big difference is in the way the robot interacts with the human body. Instead of rigidly attaching to people's joints, the Centaur uses an intelligent, elastic coupling. This system keeps the structure rigid during fast movements, but absorbs impacts and adapts to the body's natural movements. This creates a kind of cooperation between human and machine. The human remains responsible for navigation, balance, and decision-making. While the robot provides constant strength to support the weight, even though it's a system attached to the back, the device has also demonstrated quite surprising mobility. During the test, the researchers showed that the robot can climb stairs, cross uneven terrain, and make complex turns while following the user. According to the scientists, this idea could completely transform activities that involve transporting heavy loads, from disaster rescue operations to industrial logistics and military operations. All of this could be assisted by this machine. And speaking of machines, if they are already being inspired by nature or mythology, in this case, they are already changing the way robots move. Well, this next story fits perfectly into this episode, so let's focus on it. A Chinese startup called Deep Robotics recently presented a very interesting version of one of its quadruped robots. Yes, this is a robotic horse that is inspired by animal biomechanics. The special edition was launched to celebrate the Year of the Horse in the traditional Chinese calendar. But despite its symbolic appearance, the technology behind it is extremely serious. The robot is based on the Industrial Line X M20 platform, a quadruped already used in real tasks such as industrial inspection, security patrols, and operations in difficult terrain. This type of robot can reach speeds of up to 5 ms, which is close to 18 km/h. In addition, it can carry loads of up to 5 kg. And although the special version was created to celebrate the Year of the Horse, it also raises a very interesting question about the future of robotics. Do robots of the future really need to be in our shape to have a humanoid form? Or could machines inspired by animals be much more efficient? After all, a quadruped has an extremely stable base. It can walk on uneven terrain, and it distributes body weight much more efficiently than a bipedal robot. And this explains why robots inspired by animals like dogs, horses, and other creatures have been gaining more and more space in real-world applications. In agriculture, for example, these quadrupeds are already being used to solve a classic problem known as the last mile. On many farms, there are areas where tractors simply can't get in. Steep terrain, uneven ground, or even narrow regions between the plants. In these places, quadruped robots can transport equipment and heavy loads much more easily. With that, the machines are turning extremely exhausting tasks into automated processes. Deep Robotics itself is part of a group of Chinese tech startups known as the Six Little Dragons of Hangzhou. This group includes companies in artificial intelligence, robotics, and advanced technology. Recently, the company received nearly $70 million in investments, raising its market value to about $1.3 billion. But perhaps the most curious question is another one. So, if animal-inspired robots keep evolving, will we one day see machines inspired by lions, tigers, or even completely new creatures? Because in some ways, the future of robotics might end up looking much more like a technological ecosystem. A world where machines walk, run, and work not as humans, but as mechanical animals spread across the planet. If Horizon Zero Dawn came to your mind, it wasn't just a coincidence, was it? I don't think so. And while that's not happening in the real world yet, if it ever does, one of the biggest tests of the modern robotics era is starting now in Renault's factories. Take a look. The automaker has confirmed that it will deploy 350 humanoid robots in its factories within the next 18 months. Yes, it's one of the largest industrial implementations of this kind ever announced. The robots were developed by a French startup called Wondercraft, and the model used in these factories is the Calvin 40. It has some interesting features. Instead of trying to look like a human being, the design was conceived in an extremely pragmatic way. A compact torso supported by 2 self-balancing legs, and arms with modular hands that can be swapped depending on the task, as well as claws, suction cups, and industrial tools. The idea is simple. Eliminate everything that isn't essential and turn the robot into a specialized tool for industry. Currently, Calvin is already working at a Renault factory in France. His initial job is one of the heaviest tasks on the assembly line, transporting tires and automotive components. It's a repetitive, physically demanding activity that's considered not very ergonomic for human workers. Thanks to its self-balancing technology and navigation based on computer vision and artificial intelligence, the robot is able to walk autonomously through the factory and handle heavy loads without losing stability. And here's an interesting fact. Wondercraft wasn't born in the industrial sector. The company built its reputation by developing medical exoskeletons that helped people with motor disabilities walk again. And this experience with human-balanced robotics ended up becoming the perfect foundation for creating industrial humanoid robots. And the development of Calvin 40 happened in a surprisingly short time. The first functional version was created in just 40 days, but of course, it was based on more than a decade of research in self-balancing robotics. For Renault, the partnership goes beyond automation. It is part of a strategic plan that aims to reduce production costs by up to 20%. The company also announced that it wants to reduce the average number of parts per vehicle by 30%, thus speeding up the development of new cars, integrating artificial intelligence into production stages. And it's in this scenario that humanoids become an important part of the transformation. But how do you test and evolve these machines, which are becoming increasingly intelligent? Some companies have found a rather curious answer. Putting these robots to compete, in fact to fight against each other, is already well known to all of us here at Realidade. It's impressive that Engine AI from China announced that it would create a global league for combat between humanoid robots. But now they've come out publicly in an official way and said that this is really already happening over there. And the prize for the winning team is pretty big, about $1.4 million. The competition was named URKL. But there's a pretty interesting detail here. Even though the name suggests and makes it seem like there will be intense battles, robots destroying each other without any rules actually, it won't be like that, according to them. Right? For them, there won't be any violence, no spinning blades, no explosions, and nothing about destroying the opponent. Instead, the real battlefield will be the software that controls the robots. All participating teams will use the same standardized humanoid robot model, called the T800, which we're already quite familiar with around here. It measures about 1.73 meters tall and weighs approximately 75 kilograms. It will serve as a common platform for all competitors. This means that the competition won't be decided by who builds the strongest robot, but rather by who develops the best robots. Control algorithms, balance, and movement during the matches. The robots will have to demonstrate skills such as stability, body coordination, and quick response to unpredictable situations. In practice, it will be a major test of artificial intelligence applied to humanoid movement. In addition to the main prize, the competition also offers rewards for other teams, and there's even an additional incentive. The teams that make it to the top 16 will be able to keep the robot used in the competition. The 8 finalists will get direct access to job interviews at Engine AI itself. Registration is already open and will run until April 30th, with the global final scheduled to take place between December 2026 and January 2027. Deep down, this league is not just a competition, my friends. It's a smart way to accelerate the development of robotics, turning a very complex technical challenge into a true world championship of artificial intelligence embedded in robots. If you like this episode, please like and make sure you're subscribed. Thank you for staying with me until now, and just click on one of the 2 suggestions on your screen and I'll see you in the next one. Thanks for sticking with me. I can't thank you enough. Bye!